This will be a quick review for the review material covered in your Exam 1. We covered chapters 9 and 10. Chapter 9 covered expressions and how we evaluate, simplify, and translate them. Chapter 10 covered equations and how we solve them. So we're going to go quickly through some examples for each of those. First, let's look at evaluate. If we are to evaluate a plus b over 3 when a is equal to 11 and b is equal to 7, our job is to substitute 11 for a and 7 for b in the expression. So we rewrite the expression and substitute 11 for a and 7 for b. Now, order of operations says we need to take care of the numerator and denominator operations separately first. So 11 plus 7 is 18. 3 remains 3, and now we can perform the division or simplify the fraction. When we perform the division here, we get 6. If we didn't get an even division or an integer for division, we would just make sure the fraction is simplified. Let's look at another evaluate. This is 7x, evaluate 7xy when x is equal to 4 and y is equal to 2. So our job again is to substitute 4 for x in the expression and 2 for y in the expression. So when we do that, we have to show that we're multiplying the numbers because 7xy means 7 times x times y, so we need to show multiplying the numbers as well. And we substitute 4 for x and 2 for y, and then we perform the multiplication in any order. 7 times 4 times 2 in any order multiplies for 56. Okay, now let's look at looking back at our outline for the review. This is what we just covered. Okay, expressions, evaluate. Now we're going to cover expressions and how we simplify them. So what do we do to simplify? We use order of operations, and we collect or combine like terms, and we remember that like terms have the same variable and exponent. Okay? So let's look at some examples. Okay, if we're to simplify the expression, this expression has all numbers, so we know that we should have a result of just numbers. So if this is our expression to simplify, then we look at the operations. We have multiply, subtract, multiply, add. So using PEMDAS or some way to remember order of operations, we know that multiply comes before subtract or add. So we go ahead and perform that multiplying. 8 times 7 gives us 56. 6 times 6 gives us 36. So then we can rewrite the expression as 56 minus 36 and our plus 7. Right, now we can continue the order of operations. We have subtract and add, but remember, when we just have those two left, we go in order left to right. And so now we have 20 plus 7. 56 minus 36 gives us 20, bringing down our plus 7. And now all we have to do is add 20 plus 7 for 27. Let's look at another one with just numbers. If we have these numbers in operations to simplify, subtract, multiply, subtract, we know that multiply comes first. So we do that first. 3 times 4 is 12. Now we can rewrite the expression as 18 minus 12 minus 8, like this. Now we only have subtraction left, so we need to do the subtraction in order left to right. So 18 minus 12 gives us 6, and bring down our minus 8. And 6 minus 8 gives us negative 2. Now we'll start to look at some expressions that have more than just numbers. So let's look at 5 plus 6m minus 4n plus 9m minus 2n plus 1. And we want to simplify this by collecting like terms. Everything is addition or subtraction, so we want to collect like terms or combine like terms. We notice that 5 is like 1, so 5 plus 1 gives us 6. We notice that 6m is like 9m, so plus 6m plus 9m gives us plus 15m. And then minus 4n is like minus 2n. Minus 4n minus 2n gives us minus 6n. And that's where we stop the addition and subtraction because we have no more like terms. We can only add and subtract like terms. Let's look at another one. 3 plus 6x minus 5y minus 2x plus 3y minus 7. Okay, again we want to see what like terms we have. 3 is like negative 7. Now this time the signs are different. 3 and negative 7 have different signs, so we subtract 3 and 7. 7 minus 3 gives us 4, and we keep the sign of the larger absolute value. The 7 has a negative. Then we see that the 6x is like the 2x. Again, the signs are different, so we subtract. So that gives us 4x, and we keep the sign of the larger absolute value. And this time the 6 is larger, we keep the positive or plus. And then we see that 5y is like 3y. Again, the signs are different, so we subtract 5 minus 3 for 2y. Keep the sign of the larger absolute value. This time 5 is larger and it's negative. And then we check to see if everything is collected. We do no more addition and subtraction here because we have no more like terms. Let's look at one more. 5b to the 7th plus 3b to the 4th minus 2b squared plus 7b to the 7th minus 5b to the 4th. Alright, now remember that like terms have the same variable and exponent. So 5b to the 7th is like 7b to the 7th. And we could rewrite that, both signs are positive, 12b to the 7th. We see that 3b to the 4th is like minus 5b to the 4th. The signs are different, so we subtract for 2b to the 4th. Keep the sign of the larger, which is negative this time. And then that leaves us negative 2b squared with nothing like it, so it doesn't collect with anything or combine with anything, so we bring it down as is, negative 2b squared. That's all the addition that we do, or all the adding or subtracting, because we have no more like terms. None of the b's have the same variable anymore.